Hey guys, welcome to another video. I will quickly go through data structure pseudocode. So we'll be looking at the following: arrays, multidimensional arrays, lists the following data structures. I think for these three, they probably wouldn't ask you anything specifically for pseudocode. But if they are two, I think it's important remembering what these data structures are and how you would, represent them in Pseudocode. Because Pseudocode it doesn't have a strict syntax. The only syntax where it's strict is just being consistent, how you indent, and then, the main programming paradigm. So that's, um, the main three programming paradigms, that's iteration, sequence, and selection. Like, your if statements, your loops, like while loop, end while, repeat until, and for loops. Those are the only loops in Pseudocode you are allowed to use. I think outside that, nothing much. And yeah, but aside from the main programming paradigms, anything else is essentially, you can just word it in a really good way that matches what you've been doing. So if you've been capitalizing your commands, continue capitalizing them for consistency. Indent as usual, nothing too much to worry about there. We'll be looking at file handling as well. Oh, these four, however, are the little commands you kind of have to learn for file handling. So you have to know them. The nested if statements and nested loop statements. Okay, let's get to it. So a lot of people can choose to do a lot of things. For example, with these two here, this are two ways people can write it. People can also write array again here, like as if it's an array, then this, then as it is. But noting from even the two of them, what makes them good is the fact that the marker should know that it's an array, and the marker should know the fixed size, and the marker should know what data type it is of. If you are declaring an array or making an array for the first time, that is. So it'll be something like this. I'll be using just the name. And then the size, and then the data type. That's linear arrays. Now, multidimensional arrays. So, moving on to multidimensional arrays. So, for multidimensional arrays, is not too much of a difference, just noting your rows and your columns. I say this because they might represent a table for you in the exam as something you are to learn from, and it would be nice to be able to see it as rows and columns because it helps better, and also because I've matched it to a past paper where they did exactly that. Okay, let's get to it. So, like how arrays would have this form, array of integer. We could also have list of table. You would write it 2, 6 of integer. So this represents the rows and this represents the columns. Now, for such an array, let's visualize it. So it will have 2 rows, row 1 and row 2, and 6 columns, 1, 2, 3, 4, 5, 6. And then don't forget the index. So the index 0, 1, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I don't know why I added an extra. But yeah, this is what it visually, this 2-dimensional array should look like. It should form a grid, a table-like structure. Okay, so this is a solution from 2025 January, question 3E, if you're really curious. It shows a solution that they implemented using a nested for loop, and then they used this notation in terms of, yeah, the 2-dimensional notation. I will show you the question. So, you've been given information. It shows a 2D array containing 4 students: Amy, Scott, Cian, and Maxine. And I think some scores over days of weeks. Oh, a teacher is researching the length of time students spend playing computer games each day. Data is given in this 2-dimensional array with the identifier minutes played. So identifiers are containers of values. There are 2 types of identifiers in programming languages, which are variables and constants. Just in case if they ask the question, what are the 2 identifiers in programming? Variables and constants. We know what a variable is, we know what a constant is. A variable can change at any time in the program. A constant cannot change at any time in the program. Okay. So let's solve this question. Right, hence. The teacher wants to output the number of times Xian played computer games on Tuesday. Write a line of pseudocode to output the number of minutes that he played, or she played, computer games on Tuesday. That's Cyan. Cyan played computer games on Tuesday. That's Cyan, and that's Tuesday. Now, I think this is where knowing where that notation comes in is really important. So remember, rows, so you've got row Monday, row Tuesday, row Wednesday, Thursday, Friday, and indexing. Oh, they've given us the index here, so that's really cool. So index 0, 1. So index 1, and then columns. So columns they go down, so this is one column, this is another column, this is another column, then this is a row, as I've so done. So Sean's column is here. So this is what we're looking for. So they said it has an identifier mince played. So the name of the array is essentially mince played. So it will be output mince played, the row, the index of the row, and the index of the column that it is in. The index of the row is 0, 1, Tuesday, yeah? So 1, comma, the index of the column, 0, 1, 2. There you have it. There you have it. That's it for 4 marks. Damn. Honestly, damn. And then you'd still have another question that's 8 marks. So that's essentially 12 marks for Pseudocode. And I'm assuming that this same year was the year where they started the thing in question 1, where they give you a little diagram of a pseudocode and ask you what was wrong with the pseudocode or what was right with the pseudocode or what could be better. So that's extra marks for pseudocode. So that's a lot of marks for just pseudocode. So yeah, good you know this multi-dimensional array thing going. So yeah. And this is the question that had this as an answer. So I will put them in one place. Here you are. I think, what was the question? Teacher wants to add up and output the total number of minutes all the students spent playing computer games over the 5 days. Write pseudocode for this. Interesting. Now this is, I will explain what this is. Essentially, they've come here, given us a variable, total is 0, and they are looping from 0 to 3, so they are looping the columns. So for every column, I'm guessing they will loop through the row. Oh, interesting. For every column, they will loop through each row. So this is one row. So row 1, row 0 if we're looking at index. Oops. If we're looking at index, so it will loop through each row. So to go here, then it'll go here, then it'll go here, then it'll go here, then it'll go here. Plus min splayed y, the column where it is at, and the row where it is at, that's the index, the full index of where one character is. Then total will add where it is. From the other question, we realize what it takes to find. We've realized what it takes to find a cell, such as when we found the number of minutes that Sean played computer games on a Tuesday. We now know it can be represented in such a form. So these guys, they've come here. You've looped through each column, and as they're looping through each column, they will loop through each row for each column. So in this, they will add this and this and this and this and this. The for loop will then come here when y is 1, and then add this and this and this and this and this, and then come here, add this and this. That's how it'll be. So it comes here, total 0. For each column, it'll loop through each row and then add each element or cell it gets from getting the column and the row the for loop is at, wherever it is at. And then it adds a full column, and then you get to the next. Sorry, it adds a full column of rows, and then it gets to the next column, and then it does all the way until it reaches 3. That's one solution. Another solution could be, so total also be 0. I could say for x equals 0, it has to start from 0. If it starts from 1, you've lost the mark. So I'm guessing there are other ways. There definitely have to be other ways to do this. Such a way that if you've given an output, maybe if you've written this, if your loops start with 1, I think you've lost marks for that, because it just breaks array logic, because indexing must start with 0. So if your loops here in any way have 1 in them, you might lose marks. without even, like, the examiner won't even question it twice, because indexing starts from 0. Like, there's an element that is 0, 0. So if you started with a 1 in your while loop or your for loop somewhere, you've lost marks. And then how you nest it, and then how you indent. You see how this nice indentation is, this neat nested indentation. So yeah, you'd be graded on logic. Logic, what did you use? Some people could just manually add all the numbers here. That's one way to do it, but that's not really programming, is it? So yeah. Okay. So another way to do this would be, so we start with total, or I'll use my own sum equals 0. Then I'll make a for loop for each. I will be controversial and go for each row first. For each row, whereby in each row I can go through each column. So I can also invert that. So for row equals 0 to, how many rows do we have? 4. I can loop through each column. And then add it to mins played row column. That way I'm not confused. Next column, next row. So this is one line of code, this is one line of code, this is one line of code, one line of code, one line of code, one line of code. See the indentation? You indent inside a for loop, again inside a for loop, then you end your for loop with next. In the example, we ended theirs with next y and next x. So yeah, this is another way to do it. So it'll count to go to each row rather than each column, and then add up every element in every column element in that particular row, and then does the next for the same row. We could also only use one for loop if we weren't sure that nested for loops would work. I would have also gone this way, so row for row equal 0 to 4 equals 0 to 4. I could add this and this and this and this and this. Well, I'd add it manually, so it'll be like total plus the total plus mins played this plus this plus this plus this. You know what? Just remember, for a multi-dimensional array, you would have to use nested for loops. It just makes sense. Okay? Whatever other solution is out there would be marked against logic. If you started with zeros, if there was a 1, you've lost logic. How did you add each term? How did you use this expression? Did you output? And are you using correct pseudocode indentation? I wouldn't call it pseudocode indentation syntax, but you indent, you stay consistent. So even in this little example, usually in my examples, I would capitalize each. But here they made it small, but despite making it small, it was consistent. And even their variable names were consistent. So, and they used the name of the array. And all this 7 lines for just 8 marks. So, for multidimensional arrays, note it, you have to use nested for loops. Okay, next on the list would be these: sets, records, and dictionaries. A set has unique values, so I'm guessing for sets, just maybe declare what the type is, the name, and then maybe let's say set list of stuff. Then you go list of stuff dot add something. Essentially, a set just has unique values, so we don't need to stress too much about it. Then records, you could say record, the name of the record. Record stores things of more than one data type, so could have a structure, see, for example, and structure. It follows that pseudocode format, it's consistent, and it has 2 different data types in it, string and int. So this can classify as or you could say record instead of structure, and record. You're choosing just to be consistent. Then dictionaries. What are dictionaries? Dictionaries have key value pairs. So we can just say dictionary, the name of the dictionary, and then the dictionary's key. So let's say, okay, so dictionary lists, and then the key, let's give the key would be first, for example, and give it a value 17. It has key value pairs. Value can be of any data type. Key is, I think, strictly string. The value can be any data type, but the key, yeah, actually they can be of any data type, usually string. The key is usually string, but it's not expected to be. Value can be any other data type, but yeah, it holds things in key value pairs. So a dictionary, you could have something like Anna 27, let's say name and date pairings, Ross 18, that sort of thing. You've got a key and a value. It's something, I'm sure it's much more common in Python than it is in the language I'm used to. So, but again, there is no strict way to write it. What matters is that in your writing it, you are in a way kind of defining what they are. You know, unique characters, can allow multiple data types, and has key value pairs. Oh, I nearly skipped lists. So lists, well, follows the same format anyway. So list, name lists. I think lists aren't, so lists are the opposites of arrays in the sense that you don't need to give them a fixed size or a fixed data type, I think. Sorry, I am sure. Don't mind me. So lists have they don't have fixed data types or sizes. So we could just say, yeah, that should be enough in a way. Or maybe add what you want in the list. So yeah, that's a list. But to be safe, let's not put stuff of the same data type in a list. That is strictly for records. The thing is, different programming languages do a lot of stuff. So for example, I know in Python lists can tend to be like records, like a mix of a record and an array. Like you could write a list of a lot of different data types all in one thing. That's more like a record. It has more features of a record than it does an array. Okay, file handling. File handling is quite simple. You've got I'll do multi-dimensional arrays. Said that list. So let's say books registry will be a list, a new list. Actually just means list. There is no fixed number, but there could be a fixed data type. So we can say list of integers. Yeah. Records are not strictly so set name to beach, set date to 01/03/2008, end structure. Dictionaries. My dictionary of key value first. Key has the value 27. And sets are unique, so we can just say set my set and use that. Let's say my set dot add 3. If we repeated this, what do you think would be in my set? My set will only contain 3 because sets only have unique values. And then moving on to file handling. File handling, for every file you create, it must open first. So however you do it, always start with the keyword open. So open file, the name of the file, That file is usually txt for writing purposes. And then write to that file. So let's say write this text to file. Write text to file. What do you think that file will have? It will have this and then a this inside. And then you always close the file when you're done. For read, it will be open file.txt for read. Read file. Close file. If you are to output what's in a file, there are ways to do that. So it could be open file.txt for read. So read file just means it'll read everything inside that file. Read everything inside that file. Don't forget, you must close every file you open. So the moment you open a file, note that it must close. But the thing with file handling is, I think we are meant to indent what happens in between. We are meant to indent what happens in between. Yeah. It's not really looking too strict, but I would say I think we are meant to do that, because opening a file and then closing a file is like the begin and end of a program. But then usually in Pseudocode, begin and end, people can tend to not indent it and indent it. So I think that shouldn't be too much of a problem, because usually when you do begin, people can still write like linearly in it. So let's say output something, then a for loop, and then nested, but then end the for loop, or sorry, next I equals 0 to something, and usually people don't indent this part, so it shouldn't be too big of a deal. If you indent, just know if you've done open close before, you have to indent the other in between open and a close, because these things it's quite, yeah, just know when you open a file you have to close that. Okay, and then a keyword that comes to mind is EOF. Apparently means end of file. They might not ask you that, but if there is a need to do that, then you can use this to check. So if we're in the end of file, that means we're done. But while we're not in the end of file, that means we can keep going on. We could use a while loop to do this, like for example, now you indent because it's a while loop. Read file into a variable. You can just call a variable current line, for example, and then output current line. End while. and then you close the file. I think this is a much more safe option for read file. So I wrote this bit here, yeah, for read file. Don't follow it. This assumes that read file means it will read everything in that context, and when it does, it might exclude spaces, stuff like that. Either way, the text will look not what we wanted. So it's better to follow something like this, where at least we're sure it will give us something line for line. So if you were to read a file, use this syntax. If you were to output something from a file, like if it's supposed to display something from a file, then if you are to display something from a file, then go with this, and then learn this new thing, EOF, end of file, for the check. Remember, you should try to make your program robust and reliable. So with common things like even checks, at the point you'd have to use loops to check them. For example, if you are to make a program that only accepts a username that has no less than 2 characters, for example, let's say the user invalidates that necessity, and your program just lets it go because you only used if statements. That does not show robustness, because the program has allowed the user to go to enter the next part of the program with a 2-character or a 0-character name or an empty name. So you need to check it, and check it in such a way that you use a loop to make sure that the prompt keeps getting asked until the user gets it right. So that's it for data structures in Pseudocode. I think the main takeaways should be file handling and multi-dimensional arrays, and the tip that if they are to give you anything out of the blue, that thing you're writing in Pseudocode shouldn't be strictly syntax, and it shouldn't follow a syntax of a programming language. However, it should reflect whatever that programming concept is in actual programming. For example, if they were to give you OOP, I don't think they will, in Pseudocode in some way. You make it using the concepts you already know from Pseudocode, like you could use a structure or you could use a procedure, but then procedure and then end procedure, use indexing, use variables, use loops, that you use what you can, but then ensure that how you're doing it reflects what it is, like what we've talked about with records. For example, records, we know they store different data types, so something like this. Yeah, this is not explicitly what a record should look like, but it gives us something to go, oh yes, I've been inconsistent, I made a set using this and then I come here to say set. That's not good. I should say let instead, because I already have a data type set. This conflicts with what if this was in an entire Pseudocode, I would have lost marks, because I am making a set here like as a full data type, but then I came here to write set a variable. That's not good. That's not consistency. So be consistent. Use your indenting well. Understand what these things are. Take note of file handling and multi-dimensional arrays. Okay, see you in the next one. Good luck with Unit 1.